Good day, everybody. Today we shall be looking at Cambridge exam, May-June 2023, 9709, paper 5, variance 3. The first question, um, two fair coins are called at the same time repeatedly until a pair of heads is obtained. They keep throwing this coin until a pair of heads is obtained, which means it's going to follow geometric progression. When you keep doing the same thing until you have achieved a particular result, that's geometric progression. The number of throws taken is denoted by variable x. State the value of ex. Expectation of x means number of samples obtained. Number of samples obtained when two fair coins is thrown. Now, it's two fair coin. I need to draw 2 tree diagram, head, tail. This is the first tree diagram. The next tree diagram, we fill the edge of the first stone to make it 2. Head, tail, head, tail. Now let's take the sample space. The first one is head. The second one is head, tail. The next one is tail, head. And the last one is tail. When you count it, the total sample space 1, 2, 3, 4. So the expectation of x is 4 in this case. Remember, the question is saying until a pair of heads is obtained. What's probability of obtaining pair of heads? That's head. It only occur once in this sample space out of 4. Coming back to that, the next question, what they ask you to look for is ex, which is this. The next question, find the probability that exactly 5 throws are required to obtain a pair of heads. This simply means the coin on the first throw was a failure, second throw fail on the third throw, fail on the fourth throw, and obtain a pair of heads that's passed on the fifth throw. That's the meaning of exactly 5 throws are required to obtain a pair of heads. They fail 4 times before getting in at the 5th time. And probability of pair of heads is 1/4. So failure not to obtain it will be 1 minus 1/4. So failure not to obtain pair of heads is 3/4. And in the throw, they fail 4 times and pass on the 5th throw. So that will be 3/4 raised to the power 4 and pass on the 5th one multiplied by 1/4. Use your calc. You're going to have 0.0791. That is the answer. Next one, find the probability that fewer than 7 throws are required to obtain pair of heads. Fewer than 7 throws. We have a model in geometric progression. Probability of x less than r will be 1 minus q raised to the power r minus 1. That's the model under geometric progression. I'll be dropping some topical on stats, maths, further maths, physics from next week. All these analysis is there. So probability of x less than 7 will be 1 minus, what's the failure? 3/4 raised to the power 6, 7 minus 1. That gives something like this, 729 3 is past 6 is 729. 4 is past 6 is 4096. Find the LCM, do the maths. 1 minus this is going to give us 0.822. That's it. Next question. Please always make sure your answers are always in 3 significant figures. It's key. CIE specifically requested for that. 3 significant figures. Number 2, Anil is a candidate in an election. He received 40% of votes. That's probability of success. A random sample of 120 voters are chosen. This is the number. So when you have number of trials and probability of success is binomially distributed. Number of trial 120, probability of success, that's 40%, that's 40 over 100 or 2 over 5. And the question asks us, use approximation. The fact that they said we should use approximation, which means that some conditions have been met. What are the conditions? Let's check our n first. Is our n greater than 50? Yes. N is 120. Is our NP greater than 5? Let's check it. What's N? 120. What's P? 40 over 100. 0 cancels 0. 0 cancels 0. 12 times 4, we have 48 as our NP. Is it greater than 5? Yes. So once these two conditions are met, then binomially will be approximated to normal distribution. The two conditions have been met, so binomial will be approximated to normal distribution. And what are the parameters for normal? We must have our mean and our variance. Our mean, which is the same thing as our mean, is NP. Our variance is NPQ. Now, we have our mean, should be 48. Done it. Our variance is NPQ. 120 times 40% is 2 over 5. P. Q is 1 minus 2 over 5. That's 3 over 5. I think our NPQ, when you multiply, it gives us 28.8. So now the normal distribution parameters are complete. 48 and 28.8. So mean and variance. That's the first one. Now, use approximation to find probability between 36 and 54 inclusive. Now we are looking for probability that that the 120 voters, the numbers are between 36 and 54 inclusive, which means 36 and 54 they are inclusive, which means this is what we are looking for. Probability of between 36 less than or equal to x less than or equal to 54. Now, for approximation, you are going to apply continuity. Continuity means that either you add 0.5 or subtract 0.5. In this case, in this particular continuity, less than or equal to, the lower limit, which is 36, subtract 0.5. The upper limit, which is 54, subtract, add 0.5. You don't need to put the equal sign again after doing this. You don't need to put the equal sign again. So you are looking for probability of 35.5, between 35.5 and 54.5. Now, since we are using normal distribution, what's the formula for normal distribution? X minus mean all over square root of variance. So let's standardize it. That will be probability of, in this case, what's our x? 35.5 minus mean. Our mean is 48 over square root of variance. That's 28.8. After using this formula, this x here turned to z because you're standardizing it. Less than our x in the upper limit 54.5. The mean is 48 over square root of variance, which gives us probability of, subtract 35.5 minus 48 divided by square root of 38.8, it gives us minus 2.392 less than z. Do the same thing here, it gives us 1.211. Now, let me check. Okay, I see I have space. Now, NB, probability of A less than Z less than B. It means phi of B minus phi of A. But eventually, if you come across phi of negative any number, it will be 1 minus phi of positive that number. So take note of this. So now let's go back to this. Let's interpret it. So it means phi of 1.211 minus phi of negative 2.392. Like I said earlier, when you come across phi of negative number, what does it mean? 1 minus phi of positive of that number. At the end of the day, we have phi of 1.211 minus 1 plus phi of 2.392. Now let's go to the table. Let's look for phi of 1.211. Let's use table. This is the table. This is the table. We are looking for 1.211. It means 1.211. It means 1.2. Sorry, it means 1.2 under 1. That's 0. It gives us 0.8869. That 1.2 under 1. And there's still one more at the back. The last one at the back, you now trace it to under this addition here. This is the last one here. Look, is this one 1.2 under 1, and then the last one under 1 here. So we have this. So you are going to add this with this, but this will now come as 0.002 to match with the decimal number of the first one, plus 0.0002. That gives us 0.8871. So this one is 0.8871 minus 1 plus, let's do the same thing. This one with 2.3 under 9, add 2. Let's go to 2.3. 2.3, this 2.3 under 2.3 under, this 2.329. Let me check it. 2.3. I need to be sure of the last one. 2.3292. Oh, 2.3292. So 2.3 under 2 at 9. That's the meaning. 2.3 under 2. This is 2.3 under 2. This is 0, 1, 2. 2.3 under 2 give us 0.9898. And the next half number at the back is 9. Let's check 9. 9 is the last digit. So this is 9. You're going to add 2 to it. And you must match the decimal number of the first one. So it will be like plus 0.0002. That's 0.99. So this one gives us 0.99. So 0.99 plus 0.8871 minus 1. The answer gives us 0.8771. It can also be 0.877. That's it. That's the answer. Number 3. The random variable x. The random variable x take the value of 1, 2, 3, 4. X take a value of what? 1, 2, 3, 4. Such that probability of x equal to x is kx into bracket x plus a. Given that probability of x equal to 4 is 3 times probability of x equal to 2. Okay, x equal to 4. Okay, wait. Let me do it like this. Let me just draw the table once and for all here. Although I wasn't asked to draw the table, I think it will make the work easier. Now, x take the variable 1, 2, 3, 4. Probability of x equal to x. Let me take it one by one. Let me start with 1. When x is 1, it will be k times 1 plus a. When x is 1, it gives me k 1 plus a. When x is 2, that will be k times 2 plus a. I'm following that model. It gives me 2k 2 plus a. When x is 3, it will be k times 3 plus a. That gives us 3k 3 plus a. At this point, you should know when x is 4. 4k 4 plus a. When you follow that model. So when x is 4, we're going to have 4k 4 plus a. Okay, this is the table. So this is not inside the table, don't get it wrong. It should be like this. Now, the question is probability of x equal to 4. When x is equal to 4 is 3 times probability of when x equal to 2. Of course, you know that when x is 4, probability is 4k 4 plus a. When x is 2, probability is 2k 2 plus a. Let's open the bracket. 16k plus 4ka. This one will give us 12ka 12k, 2 times 2 times 3, 12k plus 6ka. Collect the like stem. 16k minus 12k, 6ka minus 4ka. This gives 4k, this one gives 2ka. K cancel k. A in this aspect will be 2. We also asked to find the value of k. Now, there's one rule you should know. Summation of all probability is always equal to 1. So which means that the first probability, k into bracket 1 plus a, where a is 2, plus the second probability, 2k into bracket 2 plus a, where a is 2. The third probability, 3k into bracket 3 plus a, where a is 2. But the fourth one, 4k into bracket 4 plus 2. When you add them together, it's 1. So here we have 3k, 2 plus 2, 4. We have 8k, 15k, 24k equal to 1. When you add them together, you're going to have 50k equal to 1. So the value of k is 1 over 50. So the question asks us to look for a and k. A is 2, k is 1 over 50. That's it. The next question. We should draw probability distribution of x. Okay, x and the probability. The first x is 1. When x is 1, of course you know that it's 3k and k is 1 over 50. So this one is 3 over 50. When x is 2, when x is 2, it's 8k, 8 over 50. When x is 3, that's 15k, 15 over 50. And when x is 4, I think it's 24k, 24 over 50. Let's check it. When x is 4, yeah. So this is the table they asked us to draw. Okay, now that's the table. Given that expectation of x is 3.2, find variance. It's given in the MF19. Variance is summation of x squared multiplied by probability minus e of x all squared. That's the formula for variance. So the variance, so the variance will be summation of x squared. The first x is 1. That will be 1 squared. What's probability? 3 over 50. You know the summation. Add. The next x is 2. It's 2 squared. What is probability? 8 over 50. The next x is 3. 3 squared. What's probability? 15 over 50. The next x is 4. 4 squared. What's probability? 24 over 50. That's for this. Minus summation, expectation of x squared. And the question, expectation is 3.2. That's 3.2 squared. So here will give us 1 squared times 3, 3 over 50. 2 squared times 8, 32 over 50. 9 squared times 15, 135 over 50. 4 squared times 24, 384 over 50. Minus 3.2 squared. All this, when you add it together, I think to give us 11.2 0.08 minus 3.2 square. That gives us 0.84. That's the answer. Question 4. The time taken a minute to complete a cycle by 19 cyclists from each of two clubs. We have two clubs, Cheetahs and Panthers, are presented back-to-back stem and leaf diagram, back-to-back. Of course, look at the key. 7, 9 means 97. And 9, 1 to the right, 91. 9, 7 to the left, 97. So, find the median and interquartile range. Now, according to the question, the total number here is 19, but it said each. So what's the formula for median? In actual sense, median is summation f over 2. But in case where your summation f is odd number, median you're going to change to summation f plus 1 over 2. Position, don't forget to put the position. So median of Cheetah, that will be 19 plus 1 over 2. Don't forget the position. So the median for Cheetah is 10th position. What's 10th position? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9 to the left, 9 in the middle. That's 99 minutes. That's how about interquartile range? Interquartile range. Interquartile range is Q3 minus Q1. So interquartile range, Q3 is upper quartile, 3/4 of n. I added 1 because it's odd number. Lower quartile Q1, 1/4 of n. I added 1 because the total number is odd number. So interquartile will now be 3/4 of 20 minus 1/4 of 20. So that one gives us what? This one gives us 15th position. This one gives us 5th position. Be careful, don't subtract. You are dealing with position. And what's the 15th position of that one? The 15th position will be, let's count it. You know, it's about Cheetah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This 15th position, 10 to the left. That's 106. How about 5th position? 3, 4, 5. This is the 5th position. 83. 83 to the left, that's 83, according to the key. 106 minus 83, that's 23 minutes. That's it. So the median is 99 minutes, while the interquartile is 23 minutes. Let's see the next question. The median and interquartile range of the Panther. Okay, let me write it down. Let me put it like this. Cheetah and Panther. Median and interquartile range. For Cheetah, the median is 99, interquartile is 23. For Panther, I think they gave us, for Panther, the median is 103, interquartile is 14. Okay, we have to make two comparisons for this. When you check this, you see that the median for Cheetah is smaller to median for Panther. You get, which means that the median for Cheetah is less than median for Panther. It means that the Cheetah, in terms of times, They are faster than that of panther. That's the meaning. Simply means the time for the cheetah, the time for the cheetah, the time for the cheetah are faster than that of panther. Once you have a lower median, it means the time is faster. At the same time, when you check this, you see that the median, sorry, the interquartile range of the cheetah is greater than interquartile range of panther. The interquartile range is about spread. This simply means interquartile is about spread. Simply means cheetahs are more spread. They are more spread. More gap. They are more spread. It's gap. They are more spread than panthers. That's the meaning. Interquartile talks about spread. Median talks about fast. How fast they have. You get. So that's the key. The next one, another cyclist, Kenny from Cheetah, also took part in the race. The mean time taken by 20 cyclists. No, Cheetah were formerly 19. So another person, Kenny, if added, everything will now become 20. That's why they said the mean time taken by the 20 cyclists from the Cheetah was 99 minutes. This is it. Formally, mean is summation x over n. Now, there will be a new mean now since Kenny has been added. The number will now increase by 1. The new mean was set to be 99. What is summation x? Summation x of the cheetah. When you add 8 plus 9, no, not 8. For cheetah, it will be, I'm talking about cheetah. I want to do summation x for cheetah. 78 plus 79. 78 plus 79 plus 80 plus 82 plus 83 plus 87 plus 88 plus 88 plus 97 plus 98 plus 99. I'm using the key. I've moved to 10 now. 101, 103, 103, 105 plus 106 plus 112 plus 118 plus 119 plus 124. When you add them together, let me add it together. I think I have 1862. So summation x is 1862 plus Kenny that was added, n plus 1, that's 19 plus 1, 20. Find the time taken by Kenny. Cross multiply. That will be 99 times 20 equal to 1862 plus Kenny that was added. 99 times 20, that's 1980, equal to 1862 plus Kenny. So 1980 minus 1862 equal to Kenny. So K that was added is 118 minutes. That's the value of K. Next question, number 5. Jasmine throw two ordinary fair six-sided dice at the same time and note the number of numbers on the uppermost faces. He notes them. Event A is defined as follows. It's two die. Let me draw a table. It's two die. First die, 1, 2, 3, 4, 5, 6. The other die, let me use this color. 1, 2, 3, 4, 5, 6. That's the two die. Put them together. He said, Kenny notes. Okay, let's write the outcome. This one can be 1, 2. No, sorry, 1, 1. This is 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Right? That's the first one. Remember that the dyes are the colored one, blue and maybe pink. Separate the dye. The outcome are in black. Now this one can be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. This is 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And the last one, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. That's the last one. Yeah. The question, A, sum of two number that is less than 6. Sum of two number that is less than 6. So let me look for probability of A. A is sum of two number less than 6. Sum of two number less than 6. Let's see it. Pay attention. Less than 6. Okay. Here is 1, 2, the sum is less than 6. 1 plus 4, the sum is less than 6. Sum that is less than 6. This one too is there. Sum that is less than 6. Sum that is less than 6. You can see what I'm thinking, but sum that is less than 6. I don't think we have more. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope you're correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10. Yeah. Sum that is less than 6. Probability is 10 over 36. Okay. I don't want to make it rough. Let me clean it. The arrow so you can look for something else. You can see sum. Oh, my line. The sum that are less than 6. I've already figured them out. Sum that is less than 6. Done that. Now the next one, let me check probability of B. B is difference. The difference between two numbers is at most 2. At most 2 means 2 and less than 2. The difference at most 2 and less than 2. Difference here is 0. Difference here is 1. It's falling. Difference here is 2. It's falling. The difference must be 2, 1 or 0, 2, 1, 0. If it's not that, it's not part of it. 1 and 4 is 3. It's out of it. Difference here is 1. Difference here is 2. Difference here is 0. Difference here is 1. Difference here is 1, 0, 1, 2. 2, 1, 0, 1, 2. This one is 2. I omitted it. This is 1, 0, 1, 2. This is 3. This is 4. 3. This is 2, 1, 0. That's it. Let's count the one of B. Difference that is at most 2. The dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. They are 24 in number. You can confirm it again. So 24 over 36. B. Let me clean it so it will make our work off. I want to clean the dot. I believe it's clear. So you've listed set A and B. We've done the probability of set A and B. Now let's see what they want us to do. So before we move on, okay. Yeah. Now the first question is this: find. Oh, no. Determine whether or not A and B are independent. Oh, question. For independent event, this is the key. Probability of A intersection B must equal to probability of A times probability of B. We know probability of A and B. Let's find A intersection B. Let's find A intersection B simply means that two numbers less than 6, two numbers, the sum less than 6. The difference between the two numbers is at most 2. You can see when you add those two numbers, they must be less than 6. When you subtract those two numbers, the difference must either give us 2, 1, or 0. This is another one. The sum of the two numbers must be less than 6. Difference is 0, 1, and 2. This one is there. Difference is 1. The sum is less than 6. Difference is 2. The sum is less than 6. Difference is not 2 here, or 1 or 0. They're out. Here, the sum is less than 6. Difference is 1. This is there. Sum is less than 6. Difference is 1. Sum, yes, sum is 6. I'm coming. Might be part of it. Because, sum is less than 6. Sorry. Sum is less than 6. Difference is 1. Difference is 2. No. Sum is less than 6. How many do you have there? And the difference is 1, 2, or 0. Sum is less than 6. How many have you done? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 altogether. The sum that is less than 6 and the difference is 2, 1, or 0. Now, probability of A intersection B is 8 over 36. Probability of A is 10 over 36. Probability of B is 24 over 36. So now 2 here is 5, 2 here is 18, 2 here is 12, 2 here is 18. 4 here is it 4? 3 here is 4, 3 here is 6. Here is 2, here is 3. At the end of the day, 2 here 1, 2 here is 9. At the end of the day, we have this to be 5 over 27. They are not equal. So they are not equal. So which means not independent. You have to write the conclusion, or else you lose your mark. They are not independent. That's it. Next question. Probability of B given A complement. That's the meaning. Find the probability of B given A complement. From Bayes' theorem, it means probability of B intersection A complement all over probability of A complement. Probability of A complement will be 1 minus probability of A. So A complement will be 1 minus, what probability of A? Probability of A is 10 over 36. 10 over 36. 36 minus 10. So A complement will be 26 over 36. Now, let's look for probability of A intersection B intersection A complement. Now, what is A itself? A is sum of two numbers less than 6. Sum of two numbers less than 6. A complement will be opposite of it. A complement will be opposite of it. Some that are greater than 6. A complement means some that are greater than 6. So please pay attention. So I'm looking for a probability of I'm looking for probability of B intersection A complement. Some that are greater, some that are greater than 6 or equal to 6, and B, and the difference is, with 2, 1, and 0. You all know B. The difference must be 2, 1, and 0. And the sum must be greater than or equal to 6. Oh, I forgot to clean that the last arrow. Let me clean it so we have a proper mark for what we are about to do now. Please, if you have a question, feel free. Comment section. Now, I'm looking for probability of intersection between difference that are 2 or 1 or 0 and the sum of the 6 or greater than 6. Okay, and the difference is 2, 1, and 0. The sum of the 6, this difference here is 4. Difference here is 5. Difference here is 2. Yeah, it's correct. Sum is 6. Difference here is 4. No. Difference here is 3. No. Difference here is 2. And the sum is greater than or equal to 6. Difference here is 1. And the sum obey the sum. Difference is 0. The sum obey the sum. Difference is 1. No, this one, sum does not obey. The sum obey the sum. And difference is 2. The sum obey the sum. The sum obey the sum. The sum obey the sum. Obey. 2 difference. Yes. 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 This. No. No. This. No, no, no. This one is not there. This one is 3. This one is yes. 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 Let's count out the one I marked. If you check out the one I marked, the sum is 6 or greater than 6. And the difference is 2, 1, or 0. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That intersection between B and A complement give us 16 over 36. Probability of A complement is 26 over 36. So that will give us 26 over 16 over 36 times 36 over 26. This cancel this. At the end of the day, we have 8 over 13. That's it. Believe you understand. Next question, number 6. We have 2 more questions to go. Number 6. The mass of grapes sold per day by a large shop can be modeled as by normal distribution. Of course, and they mentioned that the mass can be modeled by normal distribution, mean and variance, with a mean of 28 kg. The mean is 28 kg. So on 10% of days, on 10% of days, less than 16 kg grape are sold. Probability of M or S less than 16 kg is 10%. That's the meaning. Probability of M less than 16, 10%, that's 0.1. You have to find the standard deviation. So the normal distribution, the mean is 28. I don't know the variance. Okay, let me make it clear. The variance. Now let's standardize this. So using the formula for normal, that will be z less than x minus mean over square root of variance. Be careful with sign equal to 0.1. Square cancels square root. So probability of z less than 60 minus 28 is minus 12 all over standard deviation, which is equal to 0.1. Now, you should be familiar with this, that I said some z less than minus 12 over sigma mean phi. So phi is less than, it means phi of minus 12 over sigma, because it's less than, equal to 0.1. So which is the same thing as saying minus 12 over sigma. Minus 12 over sigma equal to inverse of this. Now let's go to the table and look for inverse. So that's minus 12 over sigma. So let's look for the table. Now 0.1. What can give us 0.1 inside the table? A bit trickish. 0.1, 0.1. Okay, 0.1 is not there directly. Let me look for like 0.9, 0.999 something that can approximate to 0.1. Okay. Oh, look at this. 0.8997 or 0.8810. They are close to, they are strong 0.9. Don't look for 0.9. Look for something that will approximated to 0.9. You can turn to 1. So I think, oh, this is strong. This one is strong. This one is strong. Or this is strongest, I think so. And this is not bad either. This one is not bad either. I think both of them should be accepted. So what's this one? This is my preference. It's approximately 0.1, 0.9. Coming. Let's see it. This is my preference. Let me see the one that can give me 0.1. This is 0.9 approximately. Oh, let me look at it with this 4 here. Under 2. Let me check it. This is my preference with the 4. Let me check it. 0.8997 plus 0.004. Oh, it gave me 0.9 on the dot. No. Hold on. Have I calculated this? Oh, now, sorry. I'm not done. There's a mistake here. I'm supposed to be looking for 0.9. There's a mistake here. Phi of negative. Sorry. Phi of negative means 1 minus phi of positive of it. Don't forget. I almost missed that. That's where the 0.9 is coming from. So minus phi of 12 over sigma is 0.1 minus 1. That's where my 0.9 is coming from. Minus phi of 12 over sigma. You give me 0.1 minus 1. That's minus 0.9. Minus cancel, minus. So it's now be 12 over sigma equal to inverse of 0.9. I'm sorry, it's 0.9, not 0.1. So the table, that's the reason why I said this is my preference. 0.8997. It's approximately the strongest 0.9. The strongest 0.9. So it's not 0.9 on dot, but the strongest 0.9. You have to manipulate or amalgamate. Let me use it under 4 first. Let me check under 4 and under 2. Under 4, it gives me 0.9 on dot. But under 2, let's see what it gives us. 0.8997 plus 0.002. Oh, it gives me an approximate value. So my best bet is this under 2. So that's this is 1.2 under 8 additional 2. Okay, so which means we have 12 over sigma. When you check your table, this one gives us 1.2 under 8 additional 2. That is what will give us 0.9. So from here, 12 is 1.282 sigma. So sigma is 12 over 1.282. So what's our sigma? Sigma is 9.36. That's standard deviation. 12 divided 1.282, 9.36. That's the answer. That's the standard deviation they asked us to look for. Second part. Now, the mass of grapes sold on any day is independent of the mass sold on any other day. Mass of grapes sold on any day is independent of mass sold on any other day. 12 days are chosen at random. 12 days are chosen at random. N is 12. Find the probability that less than 16. Find the probability of less than 16. And you know the probability of less than 16 is 0.1. Find the probability that less than 16 of grapes are sold. Find the probability that less than 16 kg of grapes are sold on more than 2 of these 12 days. On more than 2. On more than 2. So we are looking for probability of more than 2. It's a complex statement. It said find the probability that less than 16 kg of grape. And probability of less than 16 kg of grape from the previous question is 0.1 are sold on more than 2 of these 12 days. So from here, probability of more than 2. Of course, you know the meaning of probability of more than 2. It means 1 minus probability of less than or equal to 2. Now, it's looking like binomial distribution because we have n as 12. Probability of success is 0.1. So, and n less than or equal to 2, that would be 0, 1, 2. So, probability of more than 2 would be 1 minus. The formula is n combination r, p raised to the power r, q raised to the power n minus r for binomial distribution. N is 12. Our first r is 0, combination 0. Probability of success is 0.1 raised to the power 0. Failure is 1 minus 0.1, that's 0.9 raised to the power 12 minus 0, that's 12. Plus 12 combination 1, 0.1 raised to the power 1, 0.9 raised to the power 11, plus 12 combination 2, 0.1 raised to the power 2, 0.9 raised to the power um, um, 12 minus 2, that's 10. So at the end of the day, we have 1 minus this first one will give us 0.2824. The second one will give us 0.3766 in your calculator. The third one give us 0.2301. Add it together, 1 minus that. At the end of the day, we have 0.111. That's the probability of more than 16 kg of grape are sold on more than 2 of these 12 days. Okay, next question. C. In a random sample of 365 days, how many days would you expect mass of grapes sold to be within 1.3 standard deviation of the mean? How many of in a random sample of 365 days? Okay, let's see what they're saying. I think we need to also learn how to interpret diagram. Suspecting, this is symmetrical. Here is the mean. Here is the mean. The middle is the mean. And from this question, what's our mean? Our mean is 2.8. They said, how many days would you expect the mass of the grape sold to be within 1.3 standard deviation of the mean? Within the mean. Within the mean can be toward the right or toward the left. So if it's toward the left, he said, would you expect sold within 1.3 standard deviation of the mean? Within the mean, here will be like minus 1.3 standard deviation, while this one will be plus 1.3 standard deviation. So this is 1.3 standard deviation within the mean. Now, so from here, toward the right, is addition. Toward the right, the value of x will be 2.8 plus 1.3 this. Sorry, my symbol. And toward the left, there is subtraction. That will be 2.8 minus 2.8. So this is 2.8 toward the left minus 1.3 standard deviation. So this is our x toward the right, is our x toward the left. Let's standardize it. It said 1.3 standard deviation within the mean. 1.3 standard deviation within the mean. So it's now probability of 2.8 the minimum minus 1.3 standard deviation less than x less than 2.8 plus 1.3 standard deviation. So let's standardize it. It's x minus mean over standard deviation. X in this case is 2.8 minus 1.3 standard deviation minus our mean. Our mean is 2.8 all over standard deviation less than z. S in this case is 2.8 plus 1.3 this minus our mean 2.8 all over standard deviation, that's square root of variance. In this case 2.8 cancel minus 2.8 out, 2.8 minus 2.8 out. So what do you have left? We have minus 1.3 standard deviation over standard deviation less than z, 1.3 standard deviation over standard deviation. So this cancel this, this cancel this. So we have probability of minus 1.3 less than z less than 1.3. If you be following the question from beginning, from number 1, I'm very sure you've come across when I said this means phi of 1.3 minus phi of minus 1.3. So phi of 1.3 minus phi of negative phi, it means 1 minus phi of positive of that number. So at the end of the day, we have phi of 1.3 minus 1 plus phi of 1.3. When you check your table at the back, in your MF19, phi of 1.3 gives us 0.9032 minus 1 plus 0.9032. At the end of the day, we have 0.806. But the question asks us that in a random sample of 365 days, how many of these days do we expect the mass of grapes to be sold within what we did? So in 365 days, multiply by 365. Let's see what we have. 0.806 times 365. That's 294 points. That's 294.2, which is number of days, 2954 days. Because of decimal, I think they can also allow 295 days. There's nothing like point days. That's the answer. Thanks. Let's move to the next one. Number 7, permutation. I think it's permutation question. Find the number of different arrangements of the 10 letters in the word Casablanca in which 2 C's are not together. The word Casablanca, I think from what I can see here, I have 2 C's, 4 A's, 1 S, 1 B, 1 L, and 1 N. Total of 10. So the arrangement will be 10 factorial, the total is 10. Repetition, 2 factorial and 4 factorial. So at the end of the day, 10 factorial gives 3628800 over 2 factorial, 4 factorial. When divided, the answer gives us 75600 ways. That's it. That's the arrangement. B. Find the number of different arrangements of the 10 letters in the word Casablanca, which have an A at the beginning, an A at the end, and exactly 3 letters between the 2 C's. No, we are not done with this one. Oh, they said find the number of ways in which the 2 C's are not together. Oh, this one is when they are together. This one is when they are together. Sorry. This is when they are together. Now, let's do when. This is total anyway. This one is the total. This is the total. Let's now see when the 2 C's. When C's are together. This one is arrangement of everything total. Let's now see when the C's are together. When the C's are together like this, C, 4 A's, 1, 2, 3, 4, 1 S, 1 B, 1 L, and 1 N. So when the C's are together, it's conditional permutation. That's 1. What left? 1, 2, 3, 4, 5, 6, 7, 8. 1 is now 9. When the C's are together, you take them as 1. Everything is now 9. 9 factorial. Over what's the repetition? 4. A is repetition, 4 factorial. Now, and the repetition 4 factorial, these 2C can interchange like this. So you can also have 2 factorial. Or the arrangement can also be A, for the 2 C's to be together. A. Still going to give us the same thing. This is the best bet for it. This is it. No, it should be like this. So when the C's are together, we should have something like this. This one turn to 1. Everything 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial. Repetition is 1, 2, 3. The repetition of everything, because this one has turned to 1. These 2 C's is now in 1 position. We don't need to do the repetition. So 9 factorial or 4 factorial, we have 1, 5, 1, 20 ways. So arrangement when the 2 C's are not together will now be the total arrangement minus when they are together. So to give us 60 for 80 ways. That's it. 64 80 ways. Okay. I'm not satisfied with this method. Let's see another method. I'm not satisfied with this. I'm not satisfied with this method. It's right, but for students that are trying to perfect their permutations, I'm not satisfied with it. Let's look at the more practical approach. Let's look at the more practical approach. Okay, let's look at it practically. Find the number of different arrangements of 10 letters of the word Casablanca in which 2 C's are not together. In which 2 C's are not together. Okay, there are 10 letters and 2 C's must not be together. Those letters are we have 2 C's, 4 A's, 1 S, 1 B, 1 L, and 1 N. Aside the 2 C's, 4 plus 1, 5, 6, 7, 8. We have 8. Let me draw 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Aside the 2 C's, all these A's, 4 A's, 1 S, 1 B, 1 L, 1 N, they have 8 spaces for them. 8 spaces for them. So the arrangement will be the total spaces we have is 8 spaces, as 8 factorial. Total arrangement is for them is 8 factorial, and out of those 8 numbers, there's 4 repetition, 4 factorial. So the 2 C's can either be, because they must not be together. That's the condition. The 2 C's can either be here, or here, or here. So after arranging these ones, once you place the 2 C's can be here, they will not be together. If a number is there, C is there, C is there, a number is there. In this case, so the C's has how many spaces? How many options for them? Not arrangement now. How many options for the C's? 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 9 options. Let me say I put one C here. So the first C has 9 options. Any C that sitting in this position, it can choose out of these 9 positions. That's times 9. The other C has how many options left now? C has out of 9. C, the first C has 9 options. It can sit in anywhere. So once I put in the first C in one of the 9 positions, how many options left for the second C? 8. That's times 8. Since there are 2 C's, repetition, so divided by 2 factorial. I think this is a more practical approach. So let's now see it. So therefore, 8 factorial over 4 factorial. Let me use calculator. 8 factorial. We have 40320. 4 factorial, that's 4 times 3, 12, 12 times 2, 24. Multiplied by 9 times 8 divided by 2 factorial, 2 times 9 times 8 divided by 48, I guess. Yes, it gave us the same answer. I think I'm okay with this method. 60 for 80 ways. That's it. Let's move to the next one. I believe it's clear. The next question. The next question. Let me end this. Now, B part. The question is find the number of different arrangements of 10 letters in the word Casablanca. 10 letters in the word Casablanca, which have A at the beginning, A at the end, and exactly 3 letters in between the 2 C's. Okay, 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A at the beginning, A at the end, and exactly 3 letters in between the 2 C's. So which means if there's a C here, there must be 2 letters in between it before another C. This is one option. Another option, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A at the beginning, A at the end. The C can decide to be here. There must be 3 letters before the next C. Another option, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A at the beginning, A at the end, that's the condition. So the C can decide to be here. I've used the first, second. The C can decide to be here. 1, 2, 3. Another C will be here. So we see another option again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A at the beginning, A at the end. The C can be here. 3 between them. 1, 2, 3. Yes, this is the last option. So from here, what's the arrangement in the first one? The first one, if C is here, it's been fixed. A has been fixed. The remaining letter can be 1, 2, 3, 4, 5, 6. They have 6 ways, 6 factorial. The remaining one. Out of the remaining one, there's still 2A in the remaining one. That's repetition. 6 factorial over 2 factorial. The same thing with this one too. Is 6 factorial over 2 factorial. The same thing, you have 6 options, 6 ways in arranging them with repetition, 6 ways with repetition. So add all of them together. So there are 4. That will be 4 times 6 factorial over 2 factorial. That gives 1440 ways. That's the answer for that one. The last one, 5 letters. 5 letters. 5 letters are selected from 10 letters in the word Casablanca. Find the number of different selections in which 5 letters include at least 2 A's and at most 1 C. At least 2 A and at most 1 C. It must include at least 2 A. It can be 2 A and at most 1 C. It can be 2 A. Let's say at most 1 C means how many C do you have? 2 or 1 or nothing. But you must have at least 2A. Now there's at least 2A and at most 1 C. At most 1 C. Which means there can never be 2 C. It can only be 1 C or no C. But there must be at least 2 C. So we have 2 spaces left to make it 5. It can be at least 2A and at most 1 C. There can be at most 1 C means C or nothing. This is nothing or C. Now since A is more than 2, it can be 3 A's, at most 1 C, 1 space left. And it can be 4A. It can be 3A and no C. Exactly. It can also be 4A and 1 C. And it can also be 4 A's and no C. That's the meaning. So now for the first one, we have 2 left. 2 spaces left. And the 2 spaces left to make it, you already arranged 3. There's 3 letters. You have 2 left. So the 2 is from where? Remember that. So we have 2 spaces left. And the 2 is from where? There must be just 2A and 1 C in the first combination. So you are not going to consider C and A. So the remaining 2 must be from B, L, N, and C. That's for combination 2. In this one, there must be just 2A. There must be no C, only 2A. So you are going to consider the remaining one from 1B, 1L, 1N, 1C. The total is 4. That's for combination 3. This one, there must be just 3C, 3A, and 1C. The remaining one is still between the remaining one. That's for combination 1. Here it's for combination 2. This one is all arranged. That's 1. This one is for combination 1. So let's add them together. 4 combination 2 plus 4 combination 3 plus 4 combination 1 plus 4 combination 2. 1, 2, 3 plus 1 plus 4 combination 1. What's the total? Let's do it. Four combination 3 is what? That's 4. 4 combination 3 is 4. What's 4 combination 2? That's 6. 4 combination 1 should be 4. 4 combination 6 is 6. 2 is 6 plus 1. 4 combination 1 is 4. This is 10, 10. The answer is 25 ways. I think we are done. Thank you. Please subscribe to my channel. More content, more interesting content are coming soon. See you in the next video.